Hey geeks, Akshay Bhaskar this side. Welcome to where another session live mock interview number 41, uh, where Prateek has volunteered to go through the whole real-time technical round of DSA. Let me tell you a bit about Prateek. He is from BML Mujal University. He is a 2021 graduate and his current position is Associate Software Engineer at ServiceNow. And Anil, who is a in-house GFG mentor, and he is a ACM ICPC Asia regionalist and a candidate master on code forces. He will be Mr. Kumar will be interviewing Prateek today. So let's keep the session a bit engaging. Without delaying any further, let me invite both of them and let's start the technical round. Hi Prateek, hi Anil.
Hi
How are
Akshay.
you guys?
Hi Anil. Hi. I'm awesome. I'm doing awesome.
Oh, great Prateek. All right, Anil, you can take the lead from here. Okay.
Anil, you're on mute.
You're on mute, Anil. Can you please unmute it?
Oh, I'm sorry. Yeah,
Yeah.
it's
Okay.
fine now,
So
I guess.
yeah, Anil, you can start the process from here. I'll remove myself from this.
Okay, Akshay.
Hi
So,
Anil.
hello, Prateek.
Hi.
How are you?
I'm doing great. How about you?
So, I'm fine. So, tell me something about yourself.
Yeah. So I am from BML Munjal University. I did my B.tech in computer science and engineering, and I'm currently working as a software engineer at ServiceNow. So like I had been interning with ServiceNow since the last 6 months and just joined recently as a software engineer. So other than that, I had done previous internships as well. Like I did intern with Deloitte. So I was involved with the front end as well as back end teams there. Also, other than that, I had done some volunteering during my college days. So initially, after my first year itself, I was involved with this Swachh Bharat mission. So under that, I worked in a team in a village where we developed a prototype of a smart dustbin that was created by understanding the problems of the villagers. Like they were facing a major issue of garbage collection. So on the basis of their input, we were able to come out with this solution, and we prototyped it and presented it to the Gram Panchayat, which is like a collaborative assembly of all the sarpanch from different villages. So in that, we were also able to get orders of around 10 dustbins for our work, and like so that was a pretty big accomplishment for the team. Like we were just first year graduates getting orders for dustbins. Yeah. Other than that, I'm also in
Okay.
fitness.
So,
I'm also a fitness enthusiast. Yep. Thanks.
that's amazing. The project sounds nice. And so, there's one project in your resume basically which says that you are ranking different colleges on the basis of competitive
Yep.
coding culture, right?
Yeah.
So,
Yeah.
can you tell me something about that?
Yeah, so that was a really fun project that we came up with. So the idea was pretty new for us. Like at that time, we were in college and we were doing a lot of competitive programming. So this idea came to some of my friends' mind that okay, why not find out which are the best colleges based on their competitive coding profile. So what we did was this is based on information retrieval model. So we were studying that, and we just tried to apply something that we had learned in college. So in that we scraped the atcoder.com website, which is a famous competitive coding website. So what we did was from that website we analyzed and scraped the data of the various competitive coders and the colleges to which they belong to, or the organizations, and based on that we applied some mathematical formula to average out the coding profiles and find the ranking of colleges based on the average ratings of the users from that college. So based on that, we put forward that okay, ITMO is the best college in terms of competitive coding, MIT is second, and so on and so forth. Unfortunately, the funny thing was our college was like at one of the very last ends, so that was quite funny.
Hello, Prateek.
Can you hear me? I think there is some issue with your internet.
Hello.
Anil.
Am I au-
Can you hear me? Yep, I can hear you.
am I au- am I audible now?
Yep, I can hear you. Perfect.
Okay. So
Uh,
using
yep,
average rating of coders, right, to rank the colleges.
yep.
So like, don't you think it's a bit unfair using average ratings?
Yeah.
Like,
So
what if?
that was yeah. Yeah, so what I was saying was like we just didn't take directly the average. So what we did was there were some colleges which had just a few coders, and there were some colleges that had a large number of coders. So for that we took like there was a standard value that we took that would be used in order to compensate if there are two coders from a particular college and both are like red coders. So ultimately the college might be standing at a very high position, which it should not be because the number is a bit less on the lesser side. So to compensate that, we put forward an alpha value that was used to compensate so that if in case there are a particular college has less number of people, so on that case they will be penalized on that accordingly. So let's say if the college has less than 10 people, so there will be a certain depreciation in their average, and if a college is having more than 10 people, or there were three brackets, more less than 10, 10 to 50 and more than 50. So in order of that we were compensating if a college has more than 50 people, so we will be adding some appreciation value. If some college has less than 10 people, so we would be depreciating something from the average because like there are less people accordingly. So if there are just 10 people from a college who are like
Okay,
red coders or orange coders, so that would be accordingly wrong, right? Because the college is not performing well, but those certain small set of people are doing well. So that was the key part.
okay, that's great. That's understandable.
Yep.
So
Yep.
we are going to like this is going to be a DSA round.
Yep.
So we are going to discuss some questions. So I shared a link with you, like Google Docs link.
Yeah.
Can you please open that?
Yeah. Yeah. Got it. Should I share my screen?
Yeah, sure. Share your screen, please.
Yep. One sec. Okay.
Yeah, so Anil, I have added the question in the this thing banner, but you can show the use case of the array on your screen, Anil, or on that would be great because it is really difficult to put that in the banner.
Okay, like a question will be visible in Prateek's screen, I guess.
Yeah,
So
I have
Okay,
shared. I've shared my screen, so maybe we can
great.
add the
Okay,
question here as
just a
well.
moment. Okay, okay, fine.
so this is
Yep.
the
Got
first
it.
problem statement, Prateek.
Yeah. Okay. So you are given an array, an
You
element
can
of this
increase the
array.
font if you want to.
Yeah,
Yeah. Sure.
please
One sec.
increase the font size. Yeah, please.
One sec. Sounds good.
Okay, that's better, I guess.
So you are given an array. All the values of the array are from 1 to n. An element of this array is called special if it can be represented as the sum of two or more consecutive elements from of the array. Print the number of special elements of the given array. Okay, the number is special if it can be represented as the sum of two or more consecutive elements of the array. Okay, okay, and we have n. So okay. So here, let's go through the example one. So the question is basically, I'll be given an array and I want
Yeah,
to find out uh, how many special numbers are there, right?
right,
Number of special elements, and a special element is a number which has two, which is the sum of two or more consecutive elements. So
right.
what we can do is, so let's suppose we have this input, right? Just copy paste
Yes,
it here. So what we will have is the sum. Let's suppose if this is the range. So these are consecutive elements. So what I want to find out is if there is an element which exists which is equal to the sum of these two elements or not. So if 9 plus 5, 14 plus 2, 16 exists in the array, in that case, it will be 16 would be a special element. So what I am thinking about is what I can have is a prefix array, prefix sum array for this array, which will be having the prefix sum of the numbers. And
okay,
what I'm thinking is I can check, let's suppose if this is my subarray, I can have a map where I will store all the elements of the array, and I can check if the subarray is present, if the sum of this subarray is present or not. So that, so for example, my I pointer. So if this is my subarray I2 j, and from the prefix sum array, I can easily find out that the sum of this subarray is prefix of j minus prefix of I minus 1. So I will check if this number, this sum value is present in my array or not. That can be done via a, what do we say, a hash map, or we can do a simple vector as well of size n, because the constraints are so that all the values of the elements are inside this. So we will be able to do this in O of n square time and O of n space. So that
Okay.
was,
Can
does
can
it sound
you try to implement it? Like there are some backlogs in your approach, I guess.
okay? Okay.
We'll go over them.
Yep. Sure. Let me just. Can you see the ID?
It's not visible right now.
Just a second. Let me try sharing my screen again. Just a sec. Share screen. Uh, can you see the
Okay,
IDE now?
perfect. Yeah, it's
Yep.
visible now.
Cool. Cool. So let's suppose. Let me create a function directly. So int sol, that we will be passing. We will be getting an array, right? So
Okay.
what I can do is I will take the size of this array, and what I want to find out is I want to have a prefix array and basically a hash map of size n, or n plus 1, right?
Okay.
Because the numbers are from 1 to n plus 1 to n, right? Numbers.
Right.
So hash map we are having. So now what I want to do is I will create the prefix array. I will fill the prefix array. So so for prefix of I, what I will be doing is uh, ARR of I minus 1. Yep. So this is a prefix array, and also we will also add the numbers in the hash map. So num of ARR hash map num
Okay.
equals to
Can you
true.
increase the font? Can you increase the font? It's like not visible clearly.
Does it sound now? Does it work now?
Okay, it's better.
Should I increase further? If you want, I can do that.
You can increase a bit more, I guess.
Okay.
Okay,
Now,
that's great. Better, much better.
cool. Awesome. So now I will store the answer is my answer. So what I said earlier was I will be trying to do the Sebere part. So I will have two pointers, and I will
Right.
try to find out the Seberes and check if this is a legit Sebere or not. So Seberes can also be of size 1. Oh, so yeah, just another question that I wanted to put up is,
Yeah.
uh, can we call one number as its own Sebere? So for example, if I have 3, so 3 is not a special number, right?
Obviously not, because
Yeah,
first thing, it is already mentioned in the problem
two or
statement,
more,
right?
two or more consecutive.
Sum
Yep,
of two or
right.
more consecutive elements. Yeah.
Yeah,
And
perfect, perfect.
if we consider one element as its subarray, then the answer will
Hmm?
be obviously
Yeah,
n.
yeah,
So
perfect. Yep,
more than
sure.
one.
Okay, so taking consideration of that, so now the sum is equals to prefix of uh, k plus 1 minus prefix of I. Now I want to check is if uh, this number is present in the hash map or not. Equals to true. Also, sum should be less than n, right? Sum should be less than
Yep.
equals to n, because otherwise this can blow up. It will go out of bounds if we don't consider that. Perfect.
Right.
So if it is working, then in that case we will increment the answer, and lastly we can return the answer. let me just cross check it once. So
Sure.
we have the prefix. So prefix of 1, right? We added the numbers I to j. So this will make sure that we have at least two numbers. Sum of these two numbers will be, since it is based on one indexing, so 2 minus zi. Yep. Yep. Sounds cool to me. We can
So
also cross check via the given example if you want.
feel free to do so. Feel free.
Yep.
You can use the
Should I
example.
compile? Should I compile it or should I go through it manually? If you want, I can do that
Uh,
as well.
you can compile it, no problem.
Yeah, sure. Okay. Let me take it as input. One sec. Just a second. I'll just put in this. Uh, yep.
Okay.
Answer was not declared in this scope. Oh, sorry. There is an extra. Okay. Okay.
So
We have a problem.
right.
Yep. Okay. Okay. Yeah. Sure. Let's think about it. Let's see what's the problem here. We can check on that. So we have the array. We had the prefix sums. So prefix of I is I minus one plus that, right? And answer is zero. Perfect. N. So we are trying to take a subarray of size n. Let me check the question. And ARR. Okay. Two or more consecutive elements of the array. So two or more consecutive elements. So 0 to I to j basically. So j is 1. So in that case 2 minus is. Okay, so okay. Everybody is not. Okay, okay. Can you guide me anything like where am I missing
Uh,
here?
sure. So can you move back to the code part?
Yep, sure.
Like first thing I'd like to say, like, I think you have not got the question correctly. You have to
Okay.
count the number of special elements, right? So basically, you have to check for each element if it is special or not.
Yeah, okay, okay. Yeah. Yeah,
So that's
sorry.
one
Yeah,
thing. Like,
perfect. Yeah, that sounds good. So
so you can,
what I'm counting here is I'm counting the total number of subarrays, wherein I should be
yeah,
counting
right.
number of
Total number of
elements.
elements.
Yeah, yeah,
So
perfect.
basically, you should check for each element whether it is special or not.
Yeah, yeah, yeah. Okay, okay. So what happened here is we can just do some minor update here, and I think that should work also. So what we are checking is if summing up a particular subarray, if we get the answer, and if the answer is present, we increment the answer. After that, what we can do is we can make sure that the number is marked as false so that we don't
Okay.
count that number again.
So will this work if a number is appearing multiple times in the array? Like, is there
Hmm.
any number appearing multiple times? Like five is appearing twice in our array, right?
Yeah.
So it should be added twice to the answer. Will it add twice five? Like your code, will that code work?
No, so in that case, if we have to consider multiple occasions, so in that case, what we can do is we can remove just one instance of that element from the hash map. So, for example, if we saw that 5 was occurring two times, so I can check if this subarray 4 comma 1 is occurring once. So I will reduce occurrence of 5 one time. So now I have just one 5 to consider if 5 comes again. So for example, if in my input I had one 4 again, So if this would come, so I will still find one more 5 remaining to cater to that new subarray.
Okay.
Yeah.
So do you think your code is perfect now, or are
Yeah,
there any mistakes?
let's check. So if I got the question right, let's see. We are looking at a subarray. We are looking at a subarray, and we check if the sum is less than n. To cross check that. So yeah, if the number is having a value, if it is present in the hash map, it means that it has not been counted yet. Like it is still possessible. Uh, 1 comma 4, 4 comma 1. Okay, yeah, I think it sounds cool to me.
Okay,
If
can you
you,
compile? Uh,
yep, okay.
so
Okay, is my screen still sharing?
yeah, screen is visible.
Yep, cool. Okay, okay, so I think I'm missing something here again. Okay, J, I'm taking the prefix.
So are you calculating the prefix sum correctly? Like,
Okay, am I calculating the prefix sum? 0 to n. Yeah, I think so.
can you print it once?
Yeah, sure. 3.
So
Okay, I passed the array, right? Prefix of I. Okay, yeah, sorry.
right, that
Yep.
was the mistake.
Yeah.
Uh, Now there's another mistake. You should use array of n minus 1, right? You have taken input from 0 to n.
Uh, where are you referencing that?
Prefix of I minus 1 plus array of I. Should it be I minus 1 or I? Like, what is your indexing in array?
See, like if I am looking forward
In
to 3 plus 1,
in
and
line number 38. I'm
yeah,
talking
yeah.
about line number 38.
Okay, perfect.
Yeah, this one.
Okay, yep.
So now it's working fine.
Yeah,
So,
that was a blunder.
no, it's fine.
Yeah,
Happens to the best of us.
yeah.
So that's great. Like you solved with the best time complexity possible, which is O of n square. So I guess we can move on to the next question now.
Okay, yep,
And
sure.
let me share the next question in that doc. Okay, give me a sec.
Yeah, I can see that. Okay.
Just a second. So this is the second question. Is it visible to you?
Just a second. I think it is loading. Yep, got it.
Okay. So this is the second
Once,
question for the day.
should I increase the font if it is
Yeah, sure. You can increase it.
okay? Permutation P only be can be only modified by swapping two distinct elements. Can be modified by swapping two distinct elements. Okay. Given an n into n binary matrix A, you can swap the values of Pi and Pj. Okay, such that I is not equals to j, and if and only if ai comma j is 1. Okay. Given the permutation P and the matrix A, find the prettiest permutation you can obtain. Okay, permutation is P. Okay. So P permutation A1, A2, An is prettier than permutation B if there exists an integer k where ai.
This this
ai
basically means that A should be lexicographically smaller than B, right?
yeah,
So
okay. Okay, so basically what I'm given is I'm given permutation. Permutation means values are from 1 to n is the size of the array, like
right,
permutation of n, right? So that is the constraint. Okay, and what I'm given is I'm given this matrix. So if I comma j of the matrix is 1, in that case I can replace I comma j, element I and element j, if they are distinct. So here in this array, if I have 0 comma 2, so I can replace 2 and 3. If this is the case, 2 comma 0, I can replace 2 and 0. Okay, okay. So yeah, let's try doing that. So what we want to find out is we want to find out the lexicographical
lexicograph,
smallest,
yeah,
smallest.
lexicographically smallest permutation,
Yeah. Okay. So here, a simple way could be like brute force way would be to try to create all the combinations based on the matrix that we have been given, but that will be a bit complicated, as well as the time complexity will not be the optimal. Since what we want to
right,
do is we want to find out the lexicographical smallest, so our aim would be to bring the smaller elements to the front and like basically try to get the smaller elements to the front. So
right,
in this example, we have 3, 1, 2. I want to bring 2 to the like 1 or 2 in front of 3. So here the only option we had was to bring uh, 2 in front of 3. So yeah, okay, okay. So what? How can we go forward with this? Just give me a sec.
yeah, sure, sure, take your time.
2, 1. So what I'm thinking is I'm trying to think of a graph approach, sort of like not a graph approach, but basically where I have a particular form, like particular permutation, and
Right,
I want to go to the next step. Like I'm at 312, and what are the possible next steps do I have? So if I will replace just 2, I will swap 2 of the numbers. So that will be my next step. So here I can from 312, I could have gone to 132. So just a second. So here I am at 312. This is my current state. So if from this I could have gone to 132 if I would have swapped 1 and 3. Like although
mm,
currently this is not possible, but just hypothetical situation. Or I could have
right,
gone to something like uh, 2, 1, 3. So there would be
okay,
different paths. There would be different paths that would be going out of my current number. Okay. Mm, okay. So let's think of this fact. So we have been given that the number is a permutation. So how can this come in handy? Handy. Okay. Permutation. Can you help me out? Like where am I missing anything?
okay. Like, you have got the question correctly, I guess, but
Hmm.
like try to think if what if all the elements in the matrix are one? What can we do then?
Okay, okay. So if all the elements in the matrix are one,
Yeah,
so what we would want is we would want to sort the entire thing because all are connected. So yeah, what we can
right.
do is yeah. So I got the point somewhat. So let's suppose we can swap. There are four numbers. Let's suppose one, two, three, four, and I can swap 0 and 1,
Hmm.
and I can swap. Let's suppose 1 and 2, and let's suppose we can swap 0 and 3. So in this way, I can swap basically all are connected. So this
Right.
means that 0 can be swapped with 1, 2, and 3. Like they can be interswapped. So the optimal way that we would want to arrange them is in the sorted order, so that they are in a increasing format.
Right.
So, so what we can do is we can simply create a connected component for the elements that we have, and every component we can sort them. Like for example, if there were more elements, so these were four, so I would have five, six, seven. So what I would do is I would sort these four, and if those were disconnected, so like let's suppose they were like seven, five, and six. So if I could sort the first four, and they might be in some random order as well, but since they were all connected, my answer would be uh, 1, 2, 3, 4, 7, 5, 6.
Okay.
Since these were not connected, so I was not able to like move them in any way. But since they were connected, so I could interchange them. But let's
Right.
suppose if 7 and 6 were also connected, so we would have sorted them as well. So this would have come here, and this would have been here.
Right.
Sounds good.
So sounds correct. You can put it.
Yeah, so let's try going over this. Okay, so what we had to return, we wanted to return the smallest. So this is given as an integer array, right?
Right.
Okay, sorry. So I want to return an integer array. So okay, I am also given the matrix. Wait. Okay, so what I would want to do is I would want to find the connected component of these elements.
Right.
So let me just take in the size. Yeah. So how would I want to form the connected component? So I can do a DFS to explore the connected component. So in order to do a DFS, like come back here once again. If I'm doing a DFS, these might be arranged in some random order. So I can go from zero. I can start my DFS from zero. I will go to one. From one, I will go to two, right? And I will, since there is no other path from two, I will come back to one. From one, there is also no path, so I will come back to zero and go to three again.
Right.
So yeah. So for that, let me have this visited array, right? Uh, yeah, res. Okay. So what we want to do is we want to start our DFS um, from all the numbers. We want to check if any of the numbers is existent or not. So what we want to form is we would like to make a adjacency list or a adjacency matrix for that, but I think that we are already given in this format, so that would
Right.
not be required for the DFS. So I can pass in that grid itself as format of DFS. So what I would do is if this number is not visited already, if it is not visited, then I would want to do a DFS. And uh, so what I want to find is I want to connect all the components which are of the same number, right? So this is the
Right.
DFS count. Like, so all these numbers which will be having count equals to 1 will be connected. All the numbers will be having count equals to 2 will be connected.
Okay.
So did you get the last thing, count thing?
Yeah, 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 I got it. Like you are
So
numbering them according to their component number.
yeah, yeah. So this is the component number 1. So all the elements which are numbered with component 1, I will sort them accordingly.
Okay.
Okay, so here I have this DFS. So I'll pass in the grid. My current index is I, and this is the count. I will also have the visited matrix. Okay, yeah. So
Yep.
now let's do the DFS. So DFS is a void function. We are not doing anything with that. Okay. Okay. So we have the current, the count, and the visited array.
Okay.
If the current number is visited, then we would want to return. Like we don't want to do anything else. But if it is not visited, what we want to do is we will check if there is any other element other than this, which is part of this component. So what we will do is we will go through the entire row for that element in the grid.
Okay.
So n is equals to grid size. So what I want to do is if um, so here there was one more condition, right? That we want to just swap distinct elements.
Right.
So so to look into that condition, we would also need the array to be passed here. So
Right.
we would also require the array so that we can just check if they are unique or not. So if
But is that condition like required to get a correct answer? Like that condition is just. Don't you think that condition is just meaningless?
mm, yeah, yeah, definitely. Like since we are sorting them, yeah, yeah, definitely, yeah,
So you don't
yeah,
need to
that's right.
pass the array.
Yep, sounds good. That was a nice point. So yeah, what we wanted to do is we will check if this element current, since we are doing one indexing here, I would have to decrease one. So current comma I, if this is equals to one, uh, I would align this one. I will change the firstly the component number visited. So in the visited matrix itself, I am putting the component number for these elements.
Okay.
Okay. So now I will do is DFS. Please, please let me know if there is any confusion at any point of time in this.
Yeah. Sure. Sure.
I
Sure.
plus,
Sure.
yep, I, and the count component is the same. So here I'm basically what I'm doing is if there is a relation between the current and the ith element, if they are equal to one, it means that we can swap both of them. So what I would do is I would go to that ith element. So ith element will be now my current element, and I will put forward the count
Okay.
component count in the visited matrix. And since the count is from 1, so initially they were visited equals to 0. Sorry, if visited not equals to 0, we can just return. It means that they are part of already some component. So in this way, this will be my DFS. Yep. So
Okay.
lastly, what I would want to do is for every component, I would sort them individually, right? So how do we want to do that? So let's suppose
Okay.
the component looks something like this: 1, 2, 2, 1, 3, 3. So I want to sort this and this. So these two belong to the first component. So one way
Right.
could be one way could be to take all the numbers which are part of component 1 together and sort them and put them in their place. Okay, but that would
Okay.
so what I'm thinking is of a adjacency list, like components which are having one, like so 1 is equals to 3 and 4. These are belonging to first component, so I will sort them and I will replace them in there. original positions. Hmm. Okay, let me just think about it, how we can do it effectively. Okay.
Okay.
Okay, I have this one here. Okay. Yeah, let's make the adjacency list itself.
Okay.
Numbers. So this will be holding the numbers, whosoever will be belonging to the like to whichever component this will belong to. I will put this number in the uh, matrix
Okay.
for that component. Okay, so uh, I will put numbers of visited I. So I'm pushing in this element, ith element, since it was belonging to the visited I component. I will
Okay.
push the index of this element. That okay, since I have the element, I can sort them later according to the values corresponding to this in the array. So after this, like I have solved this thing. Now what I want to do is I want to sort all these numbers.
Yeah.
Yeah. So n sort numbers of I, numbers of I dot n. So I will make the comparator. So the comparator will be sort. Since I've passed in this value, right? I've passed in only the indexes, not the values
Right.
for this. So I want to uh, sort them and say int a. So for this, I would require in this array to be global.
Right.
Is yeah, one sec. Era global. Um, ARR global equals to ARR. So if ARR global of A is less than ARR global of, I would return this one. Right? So what this will do is this will sort the array of numbers based on the uh, values,
Values. Okay.
right? So now what is left is I have to just fill in these values based on the uh, so right now we are still having indices and we just want to push the values,
Yeah.
right? So just a second. I think I missed something here. I've sorted the indexes based on the uh, component value. Okay, but I'm still missing which positions were having the component, right? Okay, so I think I have like my answer was a little bit confusing at the end part. So what I have done is I have put in the values from different components into the different rooms. So these represent n
Okay.
rooms. So these n rooms are the component numbers. So for example, if ith element is belonging to component 1, I pushed it in the room number 1. I have
Right.
pushed only the index of the value so that I can later on sort these rooms based on the values of those indexes, right?
Okay.
So right now all the rooms, room number 1, room number 2, room number 3, which are basically the components, they are sorted based on their indexes. Now the task left is to put those values in their corresponding uh, positions. Like for example, room 1 is sorted. So if this was initially 5, and this was
Yeah.
3. I want to, since I sorted them, so the room contains now 3 comma 5. So
Right.
what I want to do is I want to fill in these values according to the uh, number. So what I can do is now I can fill in these values based on the same thing. So there are count rooms, right? So
Right.
count was the total number of rooms. So what I will do is one by one I will fill in every room. So now I will go over the uh, uh, array ARR. Let's have a separate answer array to cater to that answer size n, right? So what I will be doing is I'll be going over the elements, and if this current index is belonging to the particular room, like if this is of room 1, so what I want to
Yes.
do is I want to put an element of room number 1 at this position. So what I will do
Right.
is answer of I is equals to uh, what ARR of numbers of room number I comma index. So
Okay.
index is the current element in the room. Since, like for example, initially there were in the room number 1 there were two elements, 5 and 3.
Okay.
So currently the index was 0. So what I would put is from room number 1 I would push in the value 0, the index 0, which is uh, this will come as 0. This numbers of I comma index is the index at which 3 was there, which is
Okay. Like you are keeping a track of how many elements you have used from a particular room.
yeah, perfect, perfect.
Okay.
Yeah, and after doing this, we will increment the index as well, right?
Okay.
Yep. Let me just cross check it once again. Oh, I used the same variable, sorry. So let's name it differently. So this is room number or component number. So this is basically the component, and this is the element number. So if I have visited this element, if this number is equals to the component number, so I would be replacing this number with the component. Right? Does it make sense, or
Yeah. It
is
is
there any confusion
understandable.
here? Okay, yeah, cool. Uh, yep. So after this, we can just return the answer, because now we have sorted the elements based on their room numbers. So and
Right.
we have pushed in the values as well based on the room numbers. So I think it should make sense. Let me just go over it once again, and then we can try compiling it. So we have the array, we have the grid, global visited array. So if it is not visited, uh, then we do the DFS on this. So if it is not visited, we mark it as visited. We mark the current element as visited. Okay, 1 second. We can do it in this way. So we mark the current element as visited. After that, we check if the current element and the ith element, if they have a relation. In that case, we go to the I plus 1 ith element, and in this way we do the DFS, right? After this, we change the component, next component. So in this way, we go over all the components. If any component is having just one number, so that will also get a number. Like for example, if we had some number which was just not connected to anything else, so it will be having one number itself. So after
Right.
doing that, we want to assign the numbers to the different rooms. So if this number will be assigned to the ith room, right? Then we sorted these rooms independently. After that, the task was to fill in the answer. So we went over every component one by one, and if the number was belonging to this component, we pushed in the smallest element that was not taken at this position. Yep, makes sense. Let me try running it. One sec.
Okay.
Yeah. Okay. I'll remove this. Okay. Okay. Do you have any doubts on this? Like, if there is any confusion anywhere,
The code
where I
looks
need
fine. Like from
to?
logical point of view, it looks fine, but I think we could have improved a bit on the implementation part.
Yeah, 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 definitely. Like, I also think that this sorting part and this thing. Sorry.
Like,
Yeah, because
like
currently the time. Yeah, sorry.
we could have used something like a multi-set or something. We
Yeah,
have the room number for each element, right? So we
hmm.
can insert all the elements in a multi-set according to their
Yeah,
rule number,
yeah,
room number.
yeah,
We can
yeah,
do something like
definitely.
that.
Hmm. Hmm. Yeah, that would also have made sense. Like, instead of using a vector here, I could have made it a multi-set so that like it will
Yeah,
automatically get sorted. But the issue
and
would have been, uh, since I'm using indices, right? If I would have
yeah,
used values, I would have lost the index at which that value was occurring.
no, but we know the room number of each element, right? Like for example, let's say the room number of first element is 3. So
Yeah,
we know we have to print the element from third room.
yeah, yeah, yeah. Perfect, perfect.
Then we can just
Yeah,
print the first element and delete that one from the multiset.
yeah, yeah. Definitely. Yeah, yeah.
Yeah.
Sounds
So
good. Sounds good. Yeah, yeah. We could have
okay,
used that. Yeah. Let me just make the inputs thing. One second. Okay. Array. Yeah. Vector. Okay. Since I guess these are not space separated, these are characters, right?
yeah, right.
Yeah. Okay, one second. Let me adjust for that. Yeah, see. Okay. Yep. Yeah, let me try running it. Mm, okay, that was some error. Let me check if this is good. Okay. 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 One sec. 312001. Okay. Yep. The input is working fine. Let me
Yep.
just cross check the code once again if there is any issue at that end. Okay, so we had this ARR global, we had the visited array, we had the count. Uh, if it is not visited, I would be visiting that. Or initially, all were not visited. So we would do a DFS. I is equals to 1 to n. The count is the component count, right? So ARR count vector. Okay, if it is not visited, then if it is visited, then we return. If it is not, then we set the count number. In the other case, what we would do is we would check if the current node and the ith node is 1. If it is 1, it means that they are connected, and we want to continue the DFS mode forward. I plus 1, the count is the same, the DFS looks fine. So after the DFS, we had these room numbers. So now I want to assign the this element to this, right? Okay, yeah, so this is also okay. Now what I want to do is I want to sort these individual room numbers. Okay, I had count rooms. Right, I had count
Yeah,
number of rooms.
you can change it, but like that was not the error, I
Yeah,
guess, because
yeah,
count is
yeah.
always less than equal to n.
Yeah, yeah. So count rooms, I have count number of rooms. So all the rooms are sorted. After that, we wanted to form the answer. So sort function a and b. So if this a number is less than that, yeah, we sorted the indexes based on the values corresponding to that. Then we tried to form the answer. Component, first component, we go over the n components. We go over the n components, and for every component we have the index. And yeah, for we check the n elements. If this element belongs to this component, then we add the value to this position. Yes, looks okay to me. 0, 1, 2. Okay. Where can we missing something? Should I try to print out the rooms if it is
Yeah,
not a
sure.
problem?
Let's
Yep.
debug this one. Print out the rooms and like the adjacency matrix, the numbers.
Yeah, yeah, that only. Let me stop this. Okay, so in room number 0, okay, sorry, room number 1, we have 0. Okay, in room number 1, we have only 0.
So
Okay, 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 numbers. Okay, so we have the visited by. So here I'm like trying to check if they are allocated to the correct rooms or not.
okay.
So visited of I. So the zeroth element is allocated to the zeroth thing. Okay, so the room allocation is where the problem is. Like this is causing some issue. Okay. Mm, so here I am at the first element. Okay, yeah, got it.
Got it.
I was going, so the visited numbers are in one indexing, and I was checking from 0 to n. Like I didn't check the second element. I was checking only 0 and 1.
Is it giving correct answer now?
Let me check.
Mm. So the room numbers are correct, but like the final answer is not correct yet.
Yeah, 0, 0, 2. Okay, so this is working fine now. Uh, sorting, sorting must be also fine. This is also a part of that itself, right? Yeah,
Sorting is not working correctly.
3 1. 3 1 numbers of I. So this is index. Okay, okay. Yeah, so the indexing here is, no, it is working fine. Like 2 should come before the
Okay.
3.
Oh, right, right, right.
Yeah, right.
Index wise, it is working fine.
Yeah. So this is also working fine. Numbers is fine. Sorting is done. Okay. So I check if the number visited here. Yeah, so the problem was here. Again, visited was one indexing. This is where I caused some issue. So visited was one indexing. So I
Right.
check if the first number is part of this component. So in that case, I would add this number to the component. Yep, got
Okay,
it right.
great. Now it's working fine.
Yeah, I think like some indexing issues, like I
Yeah, right. Like
misconsidered the fact. Yeah,
we should always try to use a consistent indexing. Either
yeah,
use it zero base or either use
mm,
one base. Like
yeah. That was some issue with that.
so.
Yeah,
That's all from my side. You can ask if you have any questions for me.
yeah, sure. Let me stop sharing my screen. Yeah, so I just wanted to ask, like, what are the roles and responsibilities of, like, of you as a GFG mentor? So, how does it look like?
So let me tell you about it. So I recently joined Geeks for Geeks. Like it's been a month now, and it's a position of mentor. So obviously the responsibilities include like similar to mentorship. It's basically creating content for students, and there are other some like backend classes like the premium classes. I take classes for Geeks for Geeks Live, which is a paid course of Geeks for Geeks. And other from that, we create content, premium content and content which is available on YouTube also. So that's all basically.
Okay, so like for example, considering uh, GFG as a software company, so
Right.
what are the major challenges that the company faces in terms of handling the huge amount of data that it has, like the server issues, or what are the optimal technologies that the company tries to focus on to have an effective
Okay.
system?
To be honest, I don't have much idea about that. Like, I'm a part of mentorship team. Like, the software issue and all that part is handled by the software development team. It is a SD position, which is
Okay,
different from the mentorship team.
okay, okay. Yeah. Sounds good. Sounds good. That's awesome.
Okay.
Yep, that was mostly it from mine. Yeah.
So now, I guess coming to the feedback, like I'd like to say your logical skills and explanation part is really great. Like it's impressive. The way you explain your code and the logical thing is really good. But you can work a bit on the implementation part. Like
Yeah.
you should sometimes you jump to the logic really quickly, but you try to implement it, and there's some minor issues in the code.
Mhm.
So you can try to avoid that if you think a bit more about the
Yeah.
flow of the code. And another thing is like I guess you are just a bit rusty right now. If you practice
Yeah.
a bit more, you can do
Yeah.
it much better.
Yeah. Yeah. That's
So
really true.
that's all
Yeah.
from my
Thank you.
side for
Thank
now.
you. Thank you.
Thank you.
Thank you.
All right. Thank you, Anil. Thank you, Prateek, for doing this for our audience. And Prateek, I wish you good luck in your
Thank
career
you. Thank you
journey.
so much. Thank you so
Yeah.
much.
And Anil, thank you so much for taking time off for this, man.
Thank you, Akshay.
Kindly stay safe, stay at home, and take care of yourself. Bye,
Thank you,
Prateek.
guys.
Bye, Anil. Thanks.
Thank you
Bye.
so
Bye,
much.
Akshay.
See ya.
See you soon.
See you. Bye. All right. Chad, I hope you liked the session. And we have some more sessions coming up. We're also coming up some different workshops. So we'll definitely let you know about it as we move further. And till then, take care. Connect with us on LinkedIn if you wish. If you feel like, and Prateek's LinkedIn profile is also in the YouTube description. You can also connect with Anil if you want to. So take care, guys. Have fun. Stay at home, but be responsible.